This is problem number 41 from page 126, section 1.5, and we are modeling with quadratic equations. And this problem is from a set where we're given the same general information, and in number 41 we're asked to plug in a particular value, which is this value right here. So the problem is a projectile is launched from ground level with an initial velocity of v0 feet per second. Neglecting air resistance, its height in feet t seconds after launch is given by s equals negative 16t squared plus v0 t. For v0 equals 32, find the time or times that the projectile will A, reach a height of 80 feet, and B, return to the ground. Okay, find the times. So we are solving for t, and in part A we're given a height of 80 feet, and S represents height. So let's go ahead and substitute that value, 80, and for S into the equation, and we'll solve for t. We also need to substitute 32 in for v0. Okay, this is our quadratic equation, and chances are we're going to have to use the quadratic formula or something like that. So let's get all the terms over to one side. I don't like the leading coefficient to be negative, so I'm moving all the terms over to the left, which helps for the leading term to have a positive 16 as its coefficient. And each of these coefficients is divisible by 16, so if we divide the whole equation by 16, we get something that's a lot easier to work with. This is not factorable, so we're going to use the quadratic formula. So t is the opposite of b over 2a plus or minus the square root of b squared minus 4ac over 2a. And you may start to realize what's going on here when you simplify this. You have t, the time that it reaches the height of 80 feet is 1 plus or minus square root of, that works out to be negative 16. So since we have the square root of a negative, we actually got an imaginary number, and that does not make sense, which tells us that the projectile does not actually reach this height. Here's a way we can validate that. Did you know that in the quadratic formula, the part that's right here, which came from the opposite of b over 2a, is the x-coordinate of the vertex? So if we kind of picture this parabola that we have here in the problem, we had a negative leading coefficient, so it's a parabola that opens down. It started at the ground level, and it reaches its maximum height at whatever the x-coordinate of the vertex is at 1 second. And knowing that, we could take the number 1, we could plug it back into the equation for height. Negative 16 times 1 squared plus 32 times 1. And work that out. We'd find out that the maximum height of the projectile with the initial velocity of 32 is actually only 16. So it definitely does not reach a height of 80. Now all of this in orange here was unnecessary. It's just kind of nice to connect the ideas together. So we already know some things about parabolas. They have a vertex. The vertex in this case is the maximum. How do you find that? You can use just this part of the quadratic formula. Okay, so let's complete this part of the problem by answering the question and say that the projectile does not reach 80 feet. And we'll move on to part B. Find the times when the projectile will return to the ground, or the time that the projectile will return to the ground. Well, when you see the word ground, you want to think of that as being a height of 0. So s, the height, is 0. Put that into the equation and put the 32 in for v naught, and we're solving for t. For this particular equation, because both terms have a greatest common factor of 16 and t, we can factor that out, or we can factor out negative 16t from both terms. If you factor negative 16t out of the first term, you're left with t. And if you factor it out of the second term, you're left with minus 2. Set each factor equal to 0. Negative 16t equals 0, or t minus 2 equals 0. Divide by negative 16, we get t equals 0. Add 2, we get t equals 2. So we get two different times when the object is at ground level. This is when it started. And the one we want is t equals 2 because that is when it returned to ground level.